Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series of videos dealing with the binomial distribution, is going to concentrate on a different example. Okay, and the scenario that we're going to concentrate on is just written here. Yeah, so a bus company that runs buses from Dublin to Galway. Dublin and Galway being counties in Ireland. Okay, so you can get a bus from Dublin to Galway, and buses run from Dublin to Galway 5 times a day. Okay, let's keep that in mind. So there's 5 buses that go from Dublin to Galway, and they go at different times across the day. Okay. Now what we know is this: is that there's a 10% probability that any of its buses from Dublin will be more than 5 minutes late arriving in Galway. So it's a possibility that if you get on a bus from Dublin to Galway, that you will arrive late, and there's a 10% likelihood that the bus will be more than 5 minutes late arriving in Galway. Okay. And we know that the probabilities of buses being late are independent of each other. Okay, keep that in mind. And what I'd like to do here is we'd like to actually just answer some questions on this. The first question is, what would be the probability that on any particular day that exactly 3 buses will be more than 5 minutes late arriving in Galway? Okay, let me write that down here. So what is the likelihood? What is the probability? The probability, okay, that exactly 3 buses, okay, will be late. Okay. So if you think about this particular scenario here, this scenario is what's known as a binomial scenario. Okay, there's one of 2 things that can possibly happen. A bus either arrives in time, or a bus is late. Okay. Now, when it comes to these particular scenarios, we have a formula that we use. Okay, and the formula looks like this. It says the probability. It says P that your variable takes on a specific value, small x, is equal to n cx times p to the power of x times 1 minus p to the power of n minus x. Okay. So actually, to calculate this probability, there's a number of things that we need. We require n, the total number of objects that we have. Okay. We require p, the probability of success or failure, and x we require, which is how many of the n objects take on this particular characteristic. Okay. Now in our situation here, we're talking about bus journeys. Okay, bus journeys from Dublin to Galway. Okay, and what we know is that happens 5 times a day. So there's 5 bus journeys. So the number of objects that we have is there's 5 bus journeys. So n is equal to 5. Now, what we also know is we're given a probability, and the probability that we're given is the probability. So sorry, n is equal to 5 was provided here. There's 5 times a day. Okay, the probability is very clear. It's 10%. Okay, but what does this probability represent? It represents the probability that any of the buses will be more than 5 minutes late. So it's all about being late arriving in Galway. And so 0.10 is the probability of being late, not being early, being late. Okay? And this question, we're interested in, okay, what is the probability that exactly 3 buses will be late? So that's where our x is. In this case, it's exactly 3. Okay. So you can actually see we have all of our parameters. So what we do is we just fill it into our formula. So what we're interested in, what's the probability that exactly 3 buses will be late? This is what we need to calculate. The probability that in this scenario, out of the 5 journeys that are taken, yeah, that 3 of them arrive late. Well, it's equal to ncx, which is 5c3. So it's 5c3 times p to the power of x. Now p is 0.1 raised to the power of x, which is 3, times 1 minus p, so it's 1 minus 0.1 raised to the power of n minus x. Now n is 5 and x is 3. So what we end up with is this particular value here. Okay, but we need to work this out. So this is the combinations. It's how many ways can you select 3 objects from 5. Okay? So it's 5, second function, the NCR button, okay, 5c3 is equal to this 10 ways. So that's 10 times 0.1 raised to the power of 3 times, well, 1 minus 0.1 is 0.9 raised to the power of 5 minus 3 is equal to 2. I like to do the basic arithmetic first before I do any of the more complicated stuff. Like I like to do the subtractions, the additions, and things like that before I do exponentiation. Okay, so now you can see what we have is we have this value here, so we need to do this calculation. So this is equal to, all in one go on my calculator, it's 10 multiplied by, open bracket, 0.1 raised to the power of 3. Now my calculator is still in it, as you see the cursor is sort of flashing there. it's still in exponent mode, so I'm just going to shift it across and I close off that bracket. Multiplied by bracket 0.9 raised to the power of 2. Okay, and once again I shift it across to get out of exponent mode, which gives me a value of 0.0081. Okay? That's the probability that exactly 3 buses will be late. Okay? Maybe I'll just add something else in here. What's the probability that no buses will be late? Okay? Now this context is all about lateness. So no, none, 0. Okay? So the probability that none is late we'd have to calculate the probability that x is equal to 0. Okay? In other words, the only thing that changes here in this calculation is that x becomes 0. Okay? The other possibility is that 1 bus is late, which is the probability that x is equal to 1. The other possibility is that 2 buses is late, so x is equal to 2. The other possibility is that exactly 3 buses is late. We've already done that. The other possibility is that 4 buses is late. That's exactly 4 buses are late. And then the final possibility is exactly 5 buses is late. If that makes sense. So we have the one that we've already calculated, which is the probability that x is 3. We've already done that particular calculation. So they're the only things that can happen. No buses are late. 1 bus is late. 2 is late. 3 is late. 4 is late. 5 is late. Okay? Okay? All buses arrive on time means no bus is late. Okay? Okay? None of the buses arrive on time mean 5 buses are late. Okay? Just keep that in mind there. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And the next video will look at another alternative example with respect to the binomial distribution. Okay? So, guys, once again, thanks for watching, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. So, thank you. Bye-bye.